What I'm hoping to do today is I'm hoping to help you understand how to use Git better, more effectively, to help you become a better developer, and also to make you make better use of version control, to make it useful to you. So one of the things that I'm hoping to do too is to instill paradigms to help you think about your code. So we're going to go ahead and get started. This is the obligatory slide that everybody has, right? This is who I am. I'm TJ. Hi. I've been working with HTML, CSS, JavaScript, PHP in some form or fashion since around 2003. The way I got into it is I kind of inherited the responsibilities of a website for a small film company that I was working at, and it was e-commerce. Can you believe it? That's how I got started. Crazy. So then I became a developer at Caddis, and I worked my way up to being a senior developer there. I've built several sites there, but a couple that I'm really proud of, whitetailproperties.com, eastonhunting.com was actually one of the first sites I built while I was there. I contributed heavily to the Caddis developer standards, and I contributed to the front-end framework that they still use there at Caddis called We. I built a few add-ons. I hope that you've heard of them. If not, Ansel is the one that John Henry was talking about for image manipulation. Treasury kind of goes along with Ansel, although you can use it standalone, but it works well with Ansel for storing images or files on S3 or other SFTP servers as well. Then there's Construct, which is for building pages and or menus, Collective for global variables, and Template Sync, which I will talk a little bit more about later. So here's what we're going to cover today. We're going to talk about effective version control using a methodology called GitFlow. We're going to talk about automated deployments and how that's going to work hand in glove with GitFlow. We're going to talk about bringing it all together with a database, and then we're going to talk about best practices using ExpressionEngine with Git version control. Originally, this presentation was 1 hour and 10 minutes long when I first wrote the first draft. And I knew even then, before I knew how long we were going to be going today, that I was going to have to pare it down. So I cut a lot of stuff out of the beginning, so I'm going to be getting right into the meat and potatoes of the presentation. However, I do want to recommend, even if you're somewhat familiar with Git, this is a great tool, try.github.io. It kind of runs you through the various things you can do in the command line with Git. I do tend to use GUI applications a lot. I tend to use Tower, but I recommend that everyone get familiar with Git in the command line because that's really what Git is as a command line tool. And I think it'll make you better a developer, even if you primarily use GUI applications. So having said that, let's dive into the main topic here of GitFlow and how to make Git effective. So GitFlow is primarily a branching model. That is what GitFlow is. It helps you understand when to branch. It'll help you understand when to merge those branches back in, and it will give you a strategy for being a better developer. It's really a paradigm for thinking about your code. So what is this branching model? GitFlow is a branching model that was introduced by a developer, Vincent Dreesen. I hope I'm saying that correctly. Dreesen, I don't know. So you can read more about his proposal for this branching model in much more detail than I'm going into today at this URL. And I'm going to make all these resources available to you guys at the end of the presentation. I'll give you a link to go to get all the resources I talk about. So it's a branching model. That's what GitFlow is. And it is a workflow for feature development, staging new releases, and releasing those to production. Okay? So that's what it is. And it also for hot-fixing critical issues. I'm sure that none of us have ever had critical issues come up that we need to fix right now, right? Nobody ever had that happen. So let's talk about the branches in the GitFlow model. Now, whether you're using GitFlow or not, I'm sure you have a master branch. That's a pretty common paradigm. You can name your branches anything, but almost everybody has a master branch. In GitFlow, master is canonical. Master is always production ready. And master is considered released code. The latest commit in your master branch in GitFlow is your released code. It should always be your released code. So that's the master branch. And then the second main branch type that is always there in GitFlow is the develop branch. Okay? Sometimes people call it development or other name, but it's your develop branch. It is the integration branch. It's where you're integrating features, you're integrating hot fixes and things. You're integrating things into your develop branch, so it's your integration branch. This branch should generally be stable as you're integrating features that you've worked on into it. It's not always going to be bug-free because you're integrating things in and you have to figure out the bugs, but it should generally be stable in the GitFlow model. It should generally be ready for production because this is where you're integrating that code and you're preparing for release. This is the develop branch represents finished features that you've merged in. Okay? So let's talk a little bit more about the develop branch. Develop merges to master when the release is ready. So here's kind of a graph. You can see up here there's a graph of when you start a repository, then you branch off and you create your develop branch from master. And you make commits, you merge in commits, and you generally prepare for that release. And then when that release is ready, you merge that into master. And then you make more commits, more changes, more releases, and you push those into master, and on the cycle goes. So that's the develop branch. And then there are topic branches that you have in the GitFlow model. So let's look at those branch types. You have feature branches, you have release branches, and you have hotfix branches. Those are the three topic branch types in the GitFlow model. And here's what they do. They aid in parallel development. That means you can have many feature branches, you can have release branches, and you can have hotfix branches all going at the same time. So parallel development. It makes feature tracking clear. You create a branch for a feature. You have a one-to-one relationship with your features and your feature branches. They help you prepare for new releases. So when you create a release branch, that branch is aiding you in preparing for new releases. They ease quick fixes. You create a hotfix branch and you fix that issue that's critical that needs to be fixed in production. And the thing to note about all these topic branches is they are temporary in nature. Where we had the two main branch types that are always present in the GitFlow model, these branches come and go as you need them. So they're temporary in nature. When they are merged where they need to go, they are deleted immediately, or they should be deleted immediately. So you merge them and remove them when complete. So let's talk more about each of these branches specifically. Let's talk about feature branches. As the name indicates, feature branches are used for new features. That's what they're used for. And so they start their life by merging or by branching off of develop. So you start a new feature, you branch off develop, and you make commits. And these can be partially implemented things. You commit code, and it can be completely unstable. So a feature branch can be completely unstable because you're working on that feature. You're getting it ready to go. And so when that feature is ready to be integrated back into your code base, then you merge it back to develop. So it starts its life from develop, and it merges back into develop when it's ready. The general naming convention that we use in the GitFlow model would be feature/feature name. And this is also, I added this last minute after Kevin Cupp's talk on running tests. This would be a great place on your feature branches to run those automated tests before merging into develop. So this is where you run those tests. And one other thing that I don't have on the slide, but I want to be sure to mention, if your feature is long running, you're working on it over the course of several days, weeks, or months, you want to be merging develop into your feature branch on a regular basis. That way you're catching merge conflicts, you're catching things that need to be integrated with other code that has been merged into develop, other features that have been prepared and merged into develop. So my general practice, especially obviously when I'm working in a team where other developers are committing code and merging into develop, is to merge develop into my feature branch daily. That way I'm catching those merge conflicts that may arise. So that is the feature branch. Let's talk about release branches. Release branches are preparation for new releases. Now, you don't want to commit any new features. These are all about crossing T's and dotting I's and generally preparing your releases to go into the master branch. And the reason you would create a release branch is because, particularly again in a team environment, you may have ongoing dev preparing for other features and other releases that are not going to be in the release that you're working on. So when develop is ready to have those final preparations made for release, you branch off of develop into a release branch, as the graph illustrates, and you cross T's and you dot I's. I keep wanting to reverse those. I did it several times as I was rehearsing, so crossing I's and dotting T's really wouldn't work. So you make commits that are preparing for release. Okay, and then when your release is ready, you merge that branch into develop and master because you want those final preparations for release in both places. So once that release is ready, develop and master. And the general naming convention is release/name of release. Okay? So those are release branches. And then we have hotfix branches. And this is one of the most important things about GitFlow, or it can be. I got into kind of some trouble when I first started using Git. I had to learn how to use Git when I started developing at Caddis after I got out of the film company where I kind of got thrown into the fire in development. And I had branches in weird states, and I didn't know exactly what I was doing. And I had hotfixes come up, and I didn't know how to deal with them. This is how you deal with them, because you have master, where that hotfix is necessary and needed right now. So a hotfix branch starts its life by branching off of master. So you branch off of master into a hotfix branch, and you make commits that fix that critical issue that needs to be patched up right now. It can't wait for the next release. And when you're done, you merge it into, just like a release branch, develop and master, so that your patched code makes it into your development track and your released code. And the general naming convention that we use in the GitFlow convention is hotfix / the name of the hotfix. So those are your topic branches. Think of these topic branches as silos for your various types of code. You have in master stable code. The latest commit in master, it reflects your released code, whether it's an add-on, an application, a website, whatever it is, that reflects your released code. And then in develop, it's generally stable. It's integrating code. It's integrating your features into develop, integrating your hotfixes and things like this. So that's where integration happens, and that's your silo for integration. And then your topic branches, those 3 topic branches that we talked about, this is where unstable development happens. This is where you're committing things and you're getting that feature ready to go, and you may have partially implemented features, and that's totally fine. So that's the silo for that type of development. And you can read more about this way of thinking about branches. Actually, I didn't get the thinking of it as silos on my own. I got it from git-scm.com. You can see the link right there. So you can read much more about that there. Now, before we leave the topic branches, I want to talk about one more thing. I probably were not born in a barn, I would assume. And if you were, we can maybe come past our humble upbringing. Please prune your topic branches. I've been in some teams where the pruning didn't happen the way it should, and this is a recipe for confusion, because you create this topic branch, you create a feature branch, and then you merge it in and you leave it laying around, and even you won't remember what the state of that branch is, and you'll have to dig and figure it out. Did I merge it? Was it ready to be merged? Was I waiting to do something? I don't remember. So please prune your topic branches so that you don't have this confusion and possibly even disaster if you try to merge in a branch that wasn't ready to be merged and you don't remember the state of it. My general rule of thumb is that if you create a branch, the topic branch, you should take responsibility for it and make sure it gets deleted when that feature is done. So please prune your topic branches. Here's a tip to help you in that. Especially if you're using GitHub, and I think Bitbucket will let you do this as well with pull requests. I'm not as familiar with Bitbucket. I've used it a little bit. But GitHub in particular, you can open a pull request as soon as you have a commit in your branch that's ahead of the base branch that you want to pull against. So you can open that commit or that pull request, and you can keep making commits, but it lets you track the commit progress. You can review, and especially with the new review tools, those are amazing. So GitHub just released new review tools for pull requests. So those are really good, and you can make comments, and you can track the progress of this feature. And then most importantly, when you're done and you click merge on that pull request, you will see an option to delete that feature branch right then and there, and you've already pruned your branch and taken care of it. So this is a great tip that I've found very useful, is to use pull requests in that way. So that's the primary kind of methodology to GitFlow. But I want to talk about commits. While this is not specifically GitFlow, I consider it so related that I wanted to talk about it. So let's talk about commit philosophy. Git files have 3 states that they can be in. They can be modified, they can be staged, and they can be committed. Those are the 3 states that, as far as Git is concerned, those are the 3 states that your files exist in. So here's a typical workflow as you're working with Git. You add or modify files, and then you stage those modifications when you're getting ready to commit them. And staging takes a snapshot of those files as they exist right then and there and stores them in the staging area. You can even, if you want to for some reason, I don't usually find this useful, but you can even modify those files and the staged versions will remain as they were when you staged them. So that's a snapshot. And then you commit the staged changes. So committing takes that snapshot and stores them permanently in the repository. And rinse and repeat. That's the Git workflow. That's on a really high level. That's what you're doing with Git. So I want you to keep this in mind. Git does not know about your work until it is at the very least staged. So version control will do you no good if you have changes and something happens and they're not committed or staged. Committing is when Git takes official charge of your code and stores that snapshot in your repository. Once something is committed, it is very difficult to lose it. It is possible. You could delete all the branches that have any references to a commit and then it's gone. But in general terms, it is very difficult to lose something, to lose code once it's committed to that repository. So, with that in mind, commit early and commit often. You should be committing your code often throughout the day. You don't commit at the end of the week. You should not be committing hundreds of lines of code, because your code should be clearly defined, your commit should be clearly defined with a simple subject, and clearly definable with a simple subject. Now, you should think about it this way. The commit affects the code base in this particular way. This is what's happening to my code base. Now, there are exceptions to the hundreds of lines rule that I have there, like if you've installed an add-on, that's a pretty big add-on. But in general, when you're writing code, you don't want to get hundreds of lines of code built up in general terms. That's not what you want to do, because you're doing something very specific and then you're changing your code base in that way. If your commit does more than that, you're not committing often enough. If your commit is not defined or definable by a simple subject, you're not committing often enough. Here's a tip for writing commit messages often enough that I find extremely useful. This is something I started doing about a year and a half ago. I lose track of time. I will write my commit message before I start writing code. And this helps me stay focused as a developer, and it makes me a better developer, because now I have a goal. I am going to make this thing happen, and then I'm going to commit it. And inevitably, you're going to think of something that needs to be done or come across something that you need to do. This is a perfect opportunity to write it down or make a to-do list or open an issue on GitHub or whatever you need to do, and then come back to it after you have finished the task that you set out to do and made that commit. Now, sometimes, excuse me, sometimes you will come across something that has to be done before you can do what you intended to do. That does happen. It's inevitable. And so it's a little beyond the scope of this talk, but there is a concept in Git called stashing. If you've already done some work, you can stash those changes, go do the thing that needs to be done first, and then come back to the thing you meant to do. So I find this tip really helpful to write my commit message before I write the code that does that thing, and that helps me stay focused. All right, now I want to go really deep on this commit message thing. I have opinions about commit messages, and I'm going to share them with you. A well-formatted commit subject should always complete this sentence. When applied, this commit will fill in the blank. That's the way a well-formatted commit message should work. I find positive examples extremely helpful and useful, and generally the way that you should do positive reinforcement. So I'm going to give you some great examples of commit messages, I think. You'll notice that the sentence that we're completing is kind of in the italic gray, and then in the bold green is the actual commit subject. When applied, this commit will add a style sheet to the master template. Now that's obviously an extremely small commit, but it illustrates well the point that I'm making. This is very clear. You understand exactly what's changing in your code base. You're not giving a lot of details, but it's a nice overview of what's happening in your code base. When applied, this commit will update the README. So, again, it's very clear what's happening. We've updated something in the README. You know exactly what's happening in this code base. When applied, this commit will remove Gypsy plugin because that was an EE1 add-on. We don't even use that anymore. It doesn't work, so we need to get rid of that. When applied, this commit will update Ansel to 1.3.3. That was the released version when I wrote this slide. So these are great examples of clear commit messages that are easy to understand, and you understand what's happening in your code base. Now, while I like positive examples, I want you to notice how these don't work. When applied, this commit will changes. I'm sure I've written commit messages like this when I first started using Git. This is not helpful. This is not useful. Okay? When applied, this commit will changing to new API. Well, again, not helpful, not useful. It doesn't fit the format, but more importantly, it doesn't help us. See, when you're not writing to finish that sentence, you're probably not writing useful commit messages because you're not thinking about your commit messages well. When applied, we removed the plugin. Well, that doesn't finish the sentence. It doesn't work, and it's not helpful. Also not helpful. And I know that we've all had frustrations. We're just committing code just to get it committed and go away for the day or whatever. But that may help us relieve a little stress right now, but it's not helpful in the future. We don't know what was going on. We don't know what was going on in the code base, so it's not helpful. These are the types of things we want to avoid. Why is this important? Well, we want to know by reading the commit subject how our code base has changed. I was recently working with another developer. We were following this methodology, and whenever I would pull dev into my local version of the repository, I could quickly scan his commit subjects and see on a high level what he had done and what had changed in the code base and generally what was going on. So this is what we want to aim for. It was very nice in that environment. Clear and concise commit messages are what we're going for. I don't know if you guys have ever heard of this concept, writing code for humans. Machines don't need well-formatted commit messages, but we do. Coding, Git is part of coding, and we need to code for humans. So a year from now will thank you for these, and your fellow developers will as well. It makes writing commit messages easy. I almost always, I don't even think about it now since I'm in this methodology. I just finish that sentence in my head and the commit message just flows right out. So it makes commit messages easy. It increases the likelihood of future usefulness. Believe it or not, I've had several occasions where I needed to go back and find out what changed or revert a commit or something like that. And it was easier to find when I was writing commit messages in this style. It keeps everyone writing in the same style. That's also important. It keeps everybody on the same page. Chris Beams has a great post about commit messages. I disagreed with very little of it. I don't know about you guys. Sometimes I read something like, that is like 99% there. This was really a really good post, and so I highly recommend it. You can find it at chris.beams.io. Okay, I am really pushing the time limit here to get through the rest of my slides, so bear with me. I'm going to try to move a little faster. I want to talk about Git, ExpressionEngine, and deployments. So, okay, let's identify the problems we want to solve here in this section of my presentation. We don't want to edit code in production. I've done this. It's not a good idea. I actually edited code in production once before I was using Git, and as my FTP client was uploading, as I saved the file in my text editor, something happened with the connection. The file got partially uploaded and corrupted, and I lost the whole thing, and I had to reconstruct it. It was very bad. So we don't want to edit code in production. We don't want to miss steps in our deployment. I used to manually deploy, and I know, be careful, don't overwrite the uploads directory. Make sure you upload this thing, run the shell script. So we don't want to miss steps in our deployments. And we want to use the right database in our various environments. That's something that I see people struggling with. And hopefully many of you in this room already know about multi-environment config, but if not, we're going to help you there as well. Why automated deployments? I am a big advocate of automated deployments. And that's because, as I've mentioned, manual deployments have a high error rate. You might accidentally overwrite something, you forgot to do something, the site goes down, high error rate. We want to avoid that. We want to make releases and fixes easy. We want to remove friction from doing that. Okay, so automated deployments are extremely useful in just making it easy. We don't have to think about it anymore. We want deployments to be done the right way every time. So here's my deployment strategy. My develop branch, this works really well with the GitFlow methodology. My develop branch deploys to staging on commit. Anytime anything is pushed out to my develop branch on GitHub, it's automatically deployed to staging. The master branch deploys straight to production. Now, I don't do that one automatically, usually, unless I'm maybe the only developer and it's my site. But typically, I don't do this automatically. because I want somebody to take responsibility for pushing the button. If something does go wrong, I've not actually ever had it go wrong with automated deployments, but if it does, you want somebody there to pick up the pieces. So I usually do that one manually. And our branching model makes this easy. You can see develop maps easily to staging, and production master maps easily to production. Here are the available tools, or at least on a high level, the quick ones that come up in a Google search are the ones that I use. Here are the available tools for helping you automate your deployments. There's Beanstalk. And Beanstalk is kind of a full strategy where that's where it takes the place of GitHub. It's where you store your repository, and it also has deployment tools. It deploys over FTP or SFTP. ftploy, Capistrano. DeployBot is kind of the Beanstalk deployment system, but removed from Beanstalk. And then there's Envoyer. Okay? These are the ones that most people will recognize, and I'm sure there are many others, and I'm sure they're very good, but these are the ones that I know off the top of my head. I personally use Envoyer. I like it a lot. It is zero downtime deployment. It basically goes out over SSH, it clones that repository to your server, and it uses a symlink that it updates once the deployment is ready so that it's zero downtime. It has pre and post deployment hooks. I use both of these on my deployments, most of them. And it includes a post-deployment health check so that you know immediately if your deployment went wrong. It'll say, hey, I can't reach the site. And this takes the pain out of staging and releasing. Okay? So these are deployments. I use Envoyer. What about databases and user uploads? This is a big problem that that we've all had to solve over the years. And so I want to talk about that. Use gitignore for your user uploads. I'm sure all of you who use Git are familiar with this. You can see I have several rules in here, but you can see I store all my uploads in an uploads directory, and I'm ignoring basically everything in it. And I'm also ignoring the local development database file there. Mine is called config.local.php. Here are the general rules for being environmentally friendly. Rule number 1. Config and code flow upwards. As you commit them, they're pushed out to your servers and overwrite anything that's out there. So all your code, all your config flows up. Rule number 2 is that user data flows down. You don't want to overwrite those when you commit, particularly your uploads. So use that gitignore file and make sure that data flows back down to your development environment. I use a script to sync my uploads and my databases from staging down into my local development environment. And this is actually great. I use it even when I'm solo dev, but it's great for multi-dev environments as well, where you can have all the developers have the script in the repository, and they run the shell script, and it syncs the uploads and the database down to your local development environment. And I have a sample script for you. I'll show you the URL at the end of the presentation, but here it is right here. I take this script, I drop it into the repository, I replace a couple of these variables, and so that it's pointing to the right staging server, and you literally just go into the command line and run the script, and it does what it needs to do. And I will have a full sample of that for you at the end of the presentation. Now, what about schema changes during development? You're changing fields, field groups, channels, these sorts of things. I'm not going to lie to you, this is a hard problem to solve, and I've done it a couple of different ways over the years. Most recently, I've been using GitHub issues, checklists, pull requests, these sorts of things to track, and I try to keep it as simple as possible. So I'll say I changed the name of this channel, this field group, or well, this channel to this, or I changed this field name to this, or I added these things. For sure, any changes that you can, when you're doing it this way, if you can make changes and not affect production, do it there. But usually, you kind of have to make those changes when you're ready to deploy. So that's one strategy, but I'm actually working on an add-on. I was hoping to have it further along before this conference, but I didn't get it there. It's called Channel Sync, and it's a similar concept to what's going on with channel sets that the LS Lab team has done, but it basically it keeps JSON files up to date with the changes and the schema changes to your channels and your field groups and things. So it keeps those in JSON files, you commit them, and when you deploy, you just go to the control panel and click Sync, and it updates that schema for you. So that's something I'm working on. It's in private beta right now. If you're interested in more about that and when it's released, keep an eye on my on the Buzzing Pixel Twitter account. I am all ears for other solutions to this problem. Like I said, it is one of the pain points that I'm still working on solving, is getting schema changes bubbled up to staging and production. So that is a hard problem. And then how do we use the right database in the right environment? Most of us are probably familiar with multi-environment config. You can see this is a really simple example. This is my basic switching config for choosing the right config file in the right environment. I'm switching on the server name, and I'm doing domain.com as my production environment, staging.domain is my stage environment, and then I default to local, and then I require that file. And you can see in the background here, I have the database credentials in that file, config.local, which, as you saw earlier, is ignored, so it doesn't overwrite another developer's local config file, because sometimes they have different database setups. And I want to be sure to talk about this because we're talking about database credentials. You want to determine what should be kept out of your repository. Even if your repository is private, you're hosting your own Git repo, whatever, you should still probably keep database credentials out of your Git environment. You probably shouldn't have config.whatever your environment file is in that database, because it's just a recipe for disaster and leakage and these sorts of things. So determine what should be private and keep that out of your repo. Having said that, I want to encourage you to keep as much as possible in Git. Turn on Save Templates as Files. Is that on by default now? It used to not be, I'm not sure. But make sure that that's turned on so that your templates, your changes that you're making in your templates are all stored in version control and pushed up and taken care of. And I mentioned template sync earlier. Template sync does one thing that I consider pretty important. You may or may not know this. When you delete a template file in ExpressionEngine, then it doesn't delete it from the database, and whatever state it was in the database is what it will fall back to. So template sync simply looks at the files, and it does this in the local environment, and it'll do it if you have an environment variable set. There's instructions when you look at template sync. But basically, it will look and it will say, does this template exist in the file system? If not, it will delete it from the database. I am aware of an issue in EE 3.4. I'm working on that. So template sync, use template sync to help you with that. Use config for everything possible. Anything that's configurable should be done in the config file. If there's a config setting for it and you need to change it, do it in the config file and keep it in version control. If you're configuring a third-party add-on and it doesn't have a config setting for some config, ask the developer to add it. I miss it sometimes, but I try to make sure that all my add-ons have this as well. So configure it in the config file so it gets stored in version control. Set your upload directory preferences in config. Sorry, Robin, I had written this before I saw your presentation. I'm a big advocate of keeping everything in version control, so store your upload directory preferences in config. All right, that was a lot of information, I'm well aware, sorry. So I'm going to give you a little summary of what we talked about. GitFlow is a branching model. It helps you understand when and how to branch and how to make you a better developer. It gives you silos for your code and your development. It gives you a clear way to track features, fixes, and releases. That's GitFlow. Commit philosophy, write clear, concise commit messages. In this way, the code base will be changed in this way. That's what you're trying to do when you write a commit message. It gives you a paradigm for making you a better developer so that you stay focused and you do the thing you set out to do. You don't get distracted and go write unrelated code. And so it keeps you focused and makes you a better developer. It makes version control useful. It increases the likelihood that it will be useful to us. And then deploying a CMS. GitFlow branching makes this really easy. As you saw, the mapping of master and develop maps easily to production and staging. Automated deployment gets things right every time, and it prevents disasters in production. All right, thank you very much for your time. I hope this has been helpful to you, whether you've been using Git for a long time or not. This is the URL I kept referencing, tjdraper.github.io/presentation-eeconf-2016. You'll find all the slides. You'll find any links that I referenced. You can click on them and get right there. You can find my add-ons at buzzingpixel.com. You can follow my buzzingpixel Twitter account, or if you want anything and everything that I happen to think about that crosses my mind, you can follow my personal account.